Okay, let's continue. Well, in the last video, I forgot to introduce you two concepts. They are prior probability and posterior probability. So, for the prior probability, they just mean the probability that we can observe one feature is true or one thing happened. And the posterior probability is, the possibility of something given. So, column bar, right? The probability of something given something has already happened. So we call that posterior probability. So for example, the probability that there is really a thief given the dog barks. Okay, so those are the two concepts, prior probability and posterior probability. Okay, so and this is the process of how we can do the naive Bayes. Instead of read that to you, I'm going to walk you through how to do that with an example. So this is a very small data set, and this records whether a person would like to go play golf or not. So there are the features like outlook, temperature, number, temperature, humidity, number, and windy, and play. So the column play, yes or no, will be the feature we are going to predict. Okay, so this data set is really small. There are only 14 numbers. So if you want to calculate the the probability of yes and no, and we can easily just do the counts, right? So we can see among 14 samples there are 9 yeses and 5 nos. Okay, so the step one, we want to, for each of the feature, we want to calculate all the posterior probabilities given yes or no. So for example, if we want to take the outlook, so outlook, it is this column, and we also want to take play. So if we want to do a group by the outlook and the play, and then do a dot size, and then pandas will give you the counts of how many of the overcast on yes, and there are 4, and how many rainy on no, and there are 2, how many rainy on yes, and there are 3. So pandas will do all the counts for you, and what you need to do is just to put all the posterior probabilities together, and this is a tedious work. So for example, given it is already a yes, and remember there are total of 9 yeses, right? Given it is already an yes, and then for the overcast, and you can see there are 4 samples, right? So given it is already yes, and then the probability of overcast will be 4 divided by 9, and the same thing, say given it is already an yes, and then the sunny will be yes here, and sunny is a 2, so it will be 9. This 2 divided by 9. Okay, so we do this for overlook and play, and we also do this for temperature and play, and we move on humidity and play. So windy and play. So we only do those for the categorical features. Okay, so those posterior probabilities, they are tedious work, and we are doing nothing but the counts, and then to divide that by the number of the yeses or nos. Okay, and the next part, we want to do a prediction given a new sample. Sunny, cool, and the humidity is high, and the windy is true. So for all those features combined together, and whether this person is likely to go play golf or not, we want to make a prediction. So how do we do that? Okay, so it is sunny, right? So we know, given it is already a yes, the probability of sunny is 2 divided by 9. And then for the cool, we have the same thing. So given it is already yes, and then the probability of cool is 3 divided by 9. And eventually we have the p yes as 9 divided by 14. Okay, so we have all those parts, and then we have all those parts given the fact is a no again. So those are all the numbers we have, right? So we just count this condition. So this condition, sunny, cool, high, and true, as the condition combined as x. Okay, so the next part. Given all the features combined and then it is a yes multiplied by the yes will be, okay, the first one is sunny yes, right? Sunny yes, and 2 divided by 9, it is here. And the next one, cool, yes, and this is 3 divided by 9, this is here. And then 3 divided by 9 and 3 divided by 9. And eventually the probability of yes is 9 divided by 14. So we are just multiplying everything together. So eventually, if we put everything together, that is probability of x is there, x presents, plus it is a yes, and then we have this probability. And the same thing, if we want to calculate given the no and it is an x and multiply by the probability of no, and then we got this probability. Okay, now if we check those two values, the first one is the probability of x presents, and at the same time it is a yes, and you can see the probability is lower than given x presents, and at the same time it is a no. What does this mean? Since this probability is higher, this means if x presents, you are more likely to see a no than to see a yes. So if we want to do a prediction, we simply base it on the likelihood, and we are gonna guess the one with the higher likelihood or the higher probability, and in this case we are gonna get it is a no. Okay, so another thing we want to pay attention to is, well, the px, the probability, right? The probability is, well, the outlook equals sunny multiplied by temperature equals cool, and multiplied by humidity equals high, and the windy equals strong, and then this is this value, and we know that. And if we want to calculate the probability of given it is a yes, and then we see this feature, and then it will be the px yes and multiplied by p yes, and which is 2.2424. And if you want to see the probability of no and multiply by given no, it is an x, and it will be 29421. Okay, if you want to do this kind of comparison, and you will see the no again, it wins, right? So no matter which way you do, and you will see the probability that you observe x and there is a no, the probability will be higher than you observe the features x, feature combination x, and then it is a yes. Okay, so we are gonna, if we have to guess, we want to go for the higher probability, and which is a no in this case. Okay, and the next part, well, the naive Bayes in scikit-learn. And of course, as you can guess, in scikit-learn we have naive Bayes, and there are a total of 3 naive Bayes types, and we are going to use Gaussian naive Bayes in this case, and there are also 2 different types. There are Bernoulli naive Bayes and the multinomial naive Bayes. And for those 2 of them, they are mostly used in the text classification. So in this case, we are going to use Gaussian naive Bayes. So let's just make a very small data set. I'm only keeping those features because they are all categorical features. Okay, and then I want to do the fit. So I'm just trading that with the whole data set. So for all the categorical features, I set them as the x, and then the y will be the growth labels. And unfortunately, it doesn't work. So as you can see, could not convert string to float. Okay, so if you're doing scikit-learn and you see this kind of warning message, it means in your dataset there is one categorical feature, and unfortunately, for the scikit-learn, it cannot deal with the categorical features. So what can you do? Okay, we have already learned that, right? Okay, this video is already long enough, and I will see you in the next video. Okay?